Okay, thank you very much for including the paper to the program. So this is a joint work with Zhida from Notre Dame. He's now at the London campus for this semester, so he sends his regards from London. Now let's talk about how to harness the wisdom of crowds. Many important decisions in life are made in a group. For example, if we want to decide on the important macro policy or corporate decisions, or if we want to figure out where is the best ski resort, we all know how important that is. Or if you want to become a millionaire, decide to go on the show, remember to use Ask the Audience Lifeline, because you will get it correct 95% of the time. So a lot of studies actually show that aggregating judgments or predictions across individuals would be surprisingly accurate. And a classic demonstration is this jelly beans in the jar experiment. So if you ask a group of people how many jelly beans in the jar, the individuals will give you very diverse answers from very small number to very large number. But when you take the average, it could be accurate, remarkably accurate. This is nothing surprising because law of large number, but there is a very important component that is independence. However, in most of the social and economic setting, the subjects would submit their estimates in a sequence and main thinking herds. So what would happen? So the subjects may start follow each other's opinion, and we will get a group of people with very similar opinions, but with a large bias. And James Sorwecki actually put this very nicely in his book. The more influence we exert on each other, the more likely it is that we will believe the same things and make the same mistakes. That means it's possible that we could become individually smarter, but collectively dumber. And this is, I guess a lot of us may have similar feelings at the meetings. None of us is as dumb as all of us. So this is the downside of sequential setting. And on the other hand, there is some upside. So it may generate additional information production. So you may find the aha moment when you see others' answers, and that may increase the accuracy of your private signals, and we could become actually individually smarter and also collectively smarter. So what we are going to ask in this paper is which effect will be more dominant in the data. And specifically, we want to ask, do individuals herd in a sequential setting, and would that reduce the usefulness of information aggregation across individuals? So we're going to quantify the impact of herding on economic outcomes. And here is the empirical challenge. Because as researchers, usually we don't observe the individual's information set. And we're going to overcome this empirical challenge by directly measuring and randomizing on individuals' information set. So we're going to use the setting from a crowdsourced earnings forecaster platform called estimates.com. We think this is a very good setting because the forecasts and realizations are clearly measured and easily observable here. And also, the forecasters, like all the users, they cannot directly influence on their outcomes, which is really nice. And finally, the corporate earnings itself is also very important, not only for the firms, but also for the investors, or even for the whole financial markets. So the unique data we're going to use here is the user activity log file. And this allows us to separate the forecasts with and without the viewing prior forecasts. So that is one way we could characterize individual information sets. And we also were very lucky to run the randomized experiments with the firm so that we could restrict the information sets for randomly selected stocks and also users. I want to point out upfront, the herding we're using here actually is in a very broad sense. So you can think this as rational updating. So people do the Bayesian updating, or it could be irrational. So people underweigh their private signals. The point we want to make here is as long as individuals place positive weight on others' forecasts, that may reduce the collective intelligence. So of course, this relates to the herding literature, which is a very large literature, and including some very important work of the people in the audience. But we think by directly measuring and randomizing people's information sets, we are better able to isolate the impact of herding on economic outcomes. And we also think this paper has some broader implication on the group judgment or group decision-making, because essentially we're trying to compare the simultaneous setting versus the sequential setting. And the good thing about simultaneous setting is that it may also eliminate some inefficient strategic behavior. So now let me give you some background information about this platform, estimates.com. So this is a crowdsourcing platform of earnings forecasts. In the past, when we talk about earnings forecasts, mostly it's from the sell-side analyst on Wall Street. But now estimates actually collected from anyone from anywhere. So not only sell-side analysts, we also get the buy-side analysts, some fund managers, or other working professionals or professors or students. So basically, we just get a group of people who's very geographically diverse and also very professionally diverse. So is there any wisdom on the platform? The answer is yes. So this is not done by us. Two accounting papers actually show the estimates consensus is more accurate than Wall Street consensus most of the time. And these two consensus, they're also complementary. So if you take an average of these two, it will become even more accurate. So you may also wondering what is the incentive for people to contribute here. So the company actually creates competition among the users. The front runner, they will get some monetary prizes, several thousands each quarter, or some professional prizes. So the students may get the chance go to some fancy networking events or get mentioned on the professional magazines. And the competition will be based on this scoring system. So of course, it will reward the accurate forecasts, but more importantly, it rewards people on the way. So there is an exponential scale. Two of my colleagues, Carter and Schroeder, actually show that this kind of mechanism will encourage independent opinion and discourage information sharing and can achieve first best. So that is the first incentive. The second incentive, people also want to build a reputation. So they can keep a very useful track record so that they can show to future employer or clients. And of course, some people also do it just for altruism. So they have this social preference. They do it for the sake of wisdom of crowds. So some very simple statistics here. Our main analysis from March 2012 to March 2015, followed by a randomized experiment in the second and third quarter in 2015. Most of the firms, they are large and growth firms. The unique data we use is the user activity data. So it has a lot of information, but the most important one for us is the viewing activity on the release page. So just to give you an idea, what is the release page? So the release page has two parts. So first, you will see the chart on the left. So it tells you the actual earnings, estimates consensus, and Wall Street consensus for the past 8 quarters. And then for the current quarter, because the actual earnings is not available yet, so you can see the estimates consensus and Wall Street consensus. If you are interested in the details, you can scroll down the page, and then you will see the table on the right. So that lists all the forecasts submitted in this quarter. And we're going to create a dummy variable, characterize the viewing activity. So if the user spend more than 5 seconds on the page, the dummy variable will be equal to 1. So now let's look at the herding behavior and the influence of herding behavior on the platform. So first, to test the herding behavior, we use this information weighting regression designed by Cheng and Jiang 2006 RFS paper. So here, they regress the forecast error on the deviation. Deviation is the forecast minus pre-consensus. So the way to interpret this, you can think the deviation as the private signal minus the public signal. So when the beta is higher, that means people put more weight on the private signal. So we interact deviation with the viewing activity dummy. Here, the results tells us when people have the viewing activity, they will lower their weight on the private signal. So that means the individuals, they herd more when they view others' forecasts. And what is the influence of this herding behavior? We find the herding makes individual forecasts more accurate, but then make the consensus forecast less accurate. So let me just go through a very simple example so that you think this makes sense. So if there is a random variable with the true value 0, and everyone can get independent signal with a mean 0. So by law of large number, if we get a large group of people, the average will be very accurate. However, if now you allow herding, then people start following each other, and every one of them will be a little bit closer to the truth. But then because the upward bias will be persistent, then when you take the average, there will be a bias. So this is exactly what we find in the empirical tests. So here, this is a forecast level analysis. What we find is when there is viewing activity, the forecast error will become lower, which means the individual forecast is more accurate. But then when you look at the release level analysis, when there are more viewing activity, the absolute value of the forecast error actually becomes larger, which means the consensus becomes less accurate. The magnitude is pretty large. If you're thinking about two extreme cases, one sequence, everyone is viewing others' forecasts, and one sequence, none of the users are viewing others' forecasts, then the difference of the forecast error between these two sequences will be 3.82 cents. That is more than the distance between a perfect forecast and the forecast with a median forecast error. Another way to show this, we run the horse race between the forecast with viewing activity and without viewing activity. And we find the consensus of forecasts with viewing activity, without viewing activity, will win most of the time. So now you probably start thinking about the endogeneity problem, because the viewing activity may be endogenous. So the less informed users may be more likely to view others' forecasts. So that's why we can explain that group have a less accurate consensus. However, if you think, we also have another piece of evidence. If you look at the individual forecasts, that group of people, actually, they have more accurate individual forecasts. But in any case, to fully address the endogeneity concern, we're going to run the randomized experiment. So we did 2 rounds of experiments in the second, third quarter 2015. During the experiment, we randomly select users and disable the release page. So we asked them to make earnings forecasts without viewing any information from the platform. That is our blind forecast. After they submit the forecast, the release page is restored, and they can immediately revise their forecasts. That is the revised forecasts. And others who are not selected in this group, they can still view the original release page and make forecasts. That is our default forecasts. So give you a sense what is a blind page looks like. So if you first look at the chart, all the information for the past 8 quarters, they are exactly the same as the original release page. What is different is for the current quarter. The current quarter now, people can only see the Wall Street consensus, but they cannot see the estimated consensus. And if you scroll down the page, you will see the table, and everything is blocked here. Essentially, any information from estimated platform for the current quarter will not be available to the users on the blind page. So now let's compare the blind forecast versus the default forecasts. And what we find here is consistent with our main analysis. So the default group, they will remind you about this information weighting regression. So the higher the coefficient, meaning they put more weight on the private signal. So here the default group has a negative coefficient, means they actually lower the weight on the private signal because they just view more information from the platform. And in terms of consensus, we actually find the blind consensus will significantly beat the default consensus most of the time. And now you may think about some selection issue, because the more informed people may be more likely to contribute in their blind setting. But we don't think that's the case, because if you look at the observables, they're pretty similar, these two groups. And then if we look at the individual forecast accuracy, actually the default group, they have a more accurate individual forecast. So it doesn't look like the blind group have more information than the default group. And another test we think may be a cleaner test is to compare the blind group versus the revised forecasts, because this is just the forecast from the same person before they view the release page versus after they view the release page. And here we only do it for their first round, because a lot of people, they just revise their forecasts right after they see the release page. And in the second round, a lot of people actually waited for days to do the revision, and that makes these two groups not comparable anymore. So as for the pilot round, actually here, 10 out of the 13 releases, we find the blind group will win. So this is another piece of evidence further supports that the blind group with independent opinion will give more accurate consensus. So now, after establishing herding matters, let's explore to the extent herding matters where it will matter the most. And we want to link this to the recent social learning literature, and we think the users tend to herd more with influential users, and if the influential users make some mistakes early on, then that will lead the whole group towards the wrong direction. And that's very nice for researchers as us, because we can figure out a way to predict what is the mistakes of the influential users, and then we should be able to predict the wrong direction of the whole group. And then that leads to our second question, does the herding lead to return predictability? Because if the investors notice the wrong direction of the whole group, then they will undo the buyers in the market prices, and then there is no return predictability. But if the investors do not notice that and follow the consensus, the buyers will go to the market expectation, and then it only gets corrected during the earnings announcement. That will lead to return predictability. So how do we measure user influence? So we're going to use this PageRank algorithm. So this is also how Google ranks the websites. If we look at this graph and you think all the bubbles here are the users on estimates, and they're connected with each other by the viewing activity of each other's estimate page. So when D views A's estimate page, then we have an arrow from D to A. So in this platform, who will be influential here? There are two kinds of users will be influential. So the first one is like user B, because a lot of people is viewing B's estimate page, then whatever B says will be very, will affect others' opinions that makes B very influential. And another kind of user will be very influential here is like user C. So even though not many people are viewing C's estimate page, but then C gets a very important viewing activity from user B that also makes C influential. So to give you a sense what kind of factors are behind user influence, we regress the PageRank score on a set of variables which we think may be relevant. And here the users with high PageRank score, they are the ones who contribute a lot. They viewed a lot by others, or they have high probability to lead others' opinions. But what's interesting here is it actually do not relate to the user accuracy or the optimism bias. And we use this first to look at how herding would vary with influential users. Still use the information weighting regression. We just add one layer of interaction here, which relates to influential users. So the influence dummy equals to 1 when the number of influential users ahead of the observed users is above certain threshold. So now let's focus on the triple interaction here. That means the users with viewing activity actually will reduce their weight on the private signal even more when there are more influential users in the pre-sequence. So in other words, the users, they tend to hurt more with influential users. How am I doing?
You're doing great.
Doing great. How many minutes do I have? I think I will end it earlier. 10 minutes, okay, great. So as I just mentioned, if we could predict the influential users' error, then that will help us to predict the wrong direction of the whole group. So here we're going to explore a very simple sentiment-based measure. We're going to compare the influential users' revision with the contemporaneous stock returns. So we will have 4 kinds of combinations. First, the upward revision, positive return, upward revision, downward return, downward revision, positive return, downward revision, negative return. So now we have these 4 combinations. First, we want to confirm how the consensus will be swayed by influential users. So the dependent variable here is a directional change in the consensus error. And what we find is, indeed, the consensus will move up when influential users have an upward revision, and consensus will move down when influential users have downward revision. But what we care really is the accuracy. So in which of these 4 cases would the consensus actually becomes less accurate? Here, the dependent variable becomes the change in the absolute value of the forecast error of the consensus. And what we would expect is the 2 inconsistent cases when the influential users issue inconsistent revisions with the stock returns, we would think that is the case. The influential users are more likely to make mistakes and also lead to a less accurate consensus. And indeed, in one of these cases, we find the consensus becomes less accurate. And in this case, the influential users put upward revision while the market is tanking. So there may be too much optimism in the revision, and when the subsequent users follow the influential users, that will get into the final consensus and makes it less accurate. And how would the market react to that? So here we regress the abnormal return during earnings announcement days on the 4 kinds of counts of the 4 combinations. And indeed, in the particular case, when the influential users make mistakes, we find there is some return predictability. So here, the influential users has optimistic revision, and that will get propagated to the market expectation and leads to an overreaction of the market prices, which will get reverted during the earnings announcement days. So what is suggested here, the market actually does not seem to undo the buyers completely. So let me just conclude here. We use the data from a crowdsourcing platform to study the impact of herding on economic outcomes. And herding improves the accuracy of individual forecasts, but reduces the accuracy of consensus forecasts. And this effect is stronger when the influential users make forecasts early, and it affects asset prices. And the simple message we want to send here is that the wisdom of crowd can be better harnessed by encouraging independent voice. So we were very happy the company actually gets the message. So they actually changed the whole platform to blind setting from November 2015. And in case you are curious about the effectiveness of blind setting, as we are, so here are some results. And we are happy to report estimates actually can beat Wall Street consensus even more than before the switch. And thank you very much. Look forward to Ken's comments.